This video is presented to you by www.testprepadda.com. Dear students, from this session, I will start the discussion of chapter Electrochemistry. Electrochemistry, as the name suggests, electricity plus chemical changes. Let me tell you that in this whole chapter electrochemistry, we will deal with interrelation between electricity and chemical changes. There are two cases. Case 1, when you supply electricity, a process takes place. When electricity is supplied, chemical change takes place. And case 2, when a chemical process takes place, then energy is produced. You can see here, when electricity is supplied, a chemical change takes place. For example, conversion of H2O liquid into H2 gas plus half O2 gas. This conversion takes place when you supply electricity. And this type of transformation is called electrolysis. The process is called electrolysis, and the device which is used to carry out this electrolysis, that device is known as electrolytic cell. Okay, now case 2, chemical process which involves spontaneous redox reaction forms the basis of production of electrical energy. So here the process is spontaneous redox reaction, and the device which is used here is known as electrochemical cell, or we call that as galvanic cell. Okay, now dear students, you must have learnt about conductor and conduction in lower classes. In this chapter, I am more interested in electrical conduction and electrical conductor. You can see here, a substance that allows the flow of electricity is called electrical conductor. A substance that allows the flow of electricity through it is called electrical conductor, and this flow of electricity is known as electrical conduction. Students, the mechanism of flow of electricity is not the same for all conductors. That is why, based on the mechanism of flow of electricity, all conductors are divided into two categories. First, we call as metallic conductors, and second we call as electrolytic conductors. Here you can see, metallic conductors involve the conduction of electricity by direct flow of electrons under the influence of applied potential. For example, copper, silver, gold, iron, etc. All these are metallic conductors. These metallic conductors have got free electrons, and free electrons are responsible for the flow of electricity. In metals, we have metallic bonding. These are the nuclei of different atoms. of the metal. Consider this as metal sheet. You see electron. So basically, this is the electron of this nucleus, but it is attracted by this nucleus also. Same here, same here. So these are the free electrons, and this attraction is known as metallic bonding. And these electrons can freely move. That is why conduction takes place. Now, electrolytic conductors. Electrolytic conductors involve the conduction of electricity by the migration of free ions, positive and negative ions. For example, aqueous NaCl. Aqueous NaCl means in solution phase, we will be having Na plus and Cl minus. These two ions. Now, these two ions are free to move. That is why conduction of electricity takes place. Conduction of electricity takes place. Molten NaCl. Molten NaCl. Molten NaCl will also have Na plus and Cl minus. That is why conduction. But if I take the example of solid NaCl, solid NaCl, although NaCl is ionic compound, ionic molecule, but in solid NaCl, we do not have what? Free ions. We do not have free ions. That is why this solid NaCl will not conduct electricity. My point is clear. And students, in this chapter electrochemistry, we are more interested in electrolytic conductors, not the metallic conductors. Now, metallic as well as electrolytic, both type of conductors obey Ohm's law. Many of you must be aware of Ohm's law. Now, what is Ohm's law? You can see here the strength of current I flowing through a conductor is directly proportional to the potential difference V applied across the conductors and is inversely proportional to the resistance R, proportional to the potential difference V and inversely proportional to the resistance R. So I can write mathematically as I is equal to V by R, where I is the current measured in amperes. V is the potential difference measured in volts, and R is the resistance, electrical resistance. Dear students, in electrochemistry, instead of resistance, the term conductance is used more frequently. The term conductance, we write this as C. This term is used more frequently. The term conductance implies the ease with which the current flows through a conductor. The ease with which the current flows through the conductor. Mathematically, this conductance can be written as reciprocal of resistance. More resistance, less conductance. Less resistance, more conductance. Unit of R is what? Unit of R is ohm. We can write this as OHM or ohm. Okay, so what will be the unit of this conductance? It will be ohm inverse, or we can also say this as mho, MHO. In SI unit, we write this as Simon, and we represent this with capital S. Okay, Dear students, you must be aware of the term specific resistance. Specific resistance. Specific resistance rho is the characteristic of the material. This is defined as R into A by L. If I consider an electrolytic cell, this electrolytic material is filled inside the cell. This is the length which covers the electrolytic material, and this is the cross-sectional area. So A is cross-sectional area and this L is the length. R is the resistance. This way rho is defined. Rho is the characteristic of the material. It is independent of A or L. If you change A or L, it is R that will change, not the rho. My point is clear. What will be unit of this rho? It will be, the unit of R is ohm. If I consider the unit of A as meter square, L as meter, it will be ohm meter. Or I can write this as ohm centimeter. My point is clear. Again, in electrochemistry, we are more interested in conductance part. So instead of specific resistance, we need to understand specific conductance. Specific conductance, also known as conductivity. And we write this with K. In Greek, it is kappa. Okay, now what is this kappa? This is the electrolytic cell. These are the cell parameters, and inside the cell we have filled electrolytic solution. Okay, K is actually inverse of, or better I say reciprocal of, specific resistance. And if I substitute the value of rho, I will get this as 1 upon R into L by A. Reciprocal of resistance is what? Conductance, and L and A. These are the cell parameters. That is why we call L upon A as cell constant. Okay, so we get a formula K is equal to C into G, where K is specific conductance, C is conductance, and G is cell constant. Okay, now if we want to define this K, for that, if I take L is equal to 1 centimeter and A is equal to 1 centimeter square, then what will be the value of K? Substitute L as 1, A as 1, G will become 1, so K will be C. But at the same time, when you take length as 1 centimeter and cross sectional area as 1 centimeter square, how much material we can fill inside the electrolytic cell? Volume. How much material? 1 centimeter cube. So now you relate the two, because C is the conductance of the material. So specific conductance can be defined as what? Conductance of how much material? 1 centimeter cube. Or in a generalized manner, if I go, then specific conductance is the conductance of unit material. Here you can see specific conductance is defined as the conductance of 1 centimeter cube, or better we say unit cube of a material. Dear students, many times it becomes difficult to find cell parameters like L and A. It is difficult to measure these cell parameters accurately. So to find the cell constant, to find the value of cell constant G, we take the help of standard solution. Standard solution like KCl. And when I say standard solution here means the value of conductivity is known. Value of K is known. So value of K is known, G we have to find. So we find the conductance of KCl, whatever solution, we find conductance and then we apply formula K is equal to G into C. K is known, C we have just found, and G can be found in this manner. And this G can be used in other electrolytic solutions. My point is clear. Dear students, to compare the conductances of different electrolytic solutions, specific conductance is not the suitable quantity. Because if you change the concentration, different solutions with different concentrations may have different number of ions. Different ions means different conductance. So it is necessary to have a physically more meaningful quantity to compare the conductances of different solutions. And for that, we define two other conductivities: molar conductivity and equivalent conductivity. Dear students, in the next video lecture, I will talk about molar conductance means molar conductivity and equivalent conductance. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.